Now, we have learned about electronegativity. So what is electronegativity? Electronegativity is going to be ability of this any atom, okay, any atom to attract, okay, to attract bonding pair, okay, or okay, to attract bonding pair of electrons to itself. Okay, so to be exact, so any atom in covalent compound, okay, or covalently bonded, okay, to attract, okay, bonding pair of electrons to itself. Okay, this is the definition. And okay, this electronegativity depends on the nuclear charge. Similar to your ionization energy, it depends on the shielding effect. It also depends on, okay, the distance, okay. So distance. So if you look at, okay, group periodic table, okay, within the same period, okay, we have learned in the past, okay, where, okay, the radius becomes smaller and smaller when you go across the periodic table. Okay, why? Number one, okay, we have learned that it is becoming smaller, radius is becoming smaller. Why? Number one is because of your nuclear charge is increasing, or you can say because of the number of proton increasing. And okay, in this case, okay, shielding effect remains constant because the same number of shells. Okay, shielding effect is going to be constant. And we know the distance, okay, in this case, the radius is decreasing related to your distance. Now, what happens, okay, when you go across, if you want to relate to your ionization energy, energy required to remove one electron from the atom, gaseous atom, to give you positive one gaseous ion. Yeah. So the ionization energy increases. What? Difficult to remove, yeah, because strongly bonded. But now, okay, we are going to relate this, okay, with our, okay, electronegativity. Our electronegativity is going to become ability is going to be more, okay. Electronegativity is more when you go across the periodic table. Same reason, nuclear charge is more, okay, shielding effect is remain constant. The nucleus will have greater attraction towards the electron, therefore they can attract the electrons closer to themselves. So generally, okay, any elements that is on the right side of the periodic table, the electronegativity is going to be quite high, especially when you look at, okay, group NOF. Okay, so nitrogen is group 15. Okay, oxygen is group 16. Fluorine is going to be group 17. And we know that fluorine is going to be the most electronegative. Okay, the most electronegative. Why? Because fluorine is going to be towards the end of the periodic table on the right hand side. Okay. The same thing when you go down the group, okay, we know that now nuclear charge is increasing, okay, but because there is increase in the number of shell, okay, the shielding effect is more, distance is more. Both shielding effect and distance, okay, they will outweigh, okay, they will outweigh the increase in the nuclear charge. Therefore, okay, ionization energy decreases, easier to remove the electron. The same thing, okay, electronegativity is also going to be ability to attract the electron will also decrease. Okay, so please remember that. Now, we know, okay, electronegativity, we can refer to, you guys can hear me. Eshana say you don't understand. Eshana, what do you don't understand? Why does decrease across the period? Okay, it decreases across the period. Now you look at the ability. Okay, so Eshana, electronegativity is the ability to attract the electron. So if ionization energy, okay, is going to be increasing, it means it is going to be holding to its electron, okay, closer. So it means this electron, okay, this particular electron is held closer. Of course, the nucleus over here, they are quite strong. Okay, they are quite strong. It means the electron, if you have any bonding pair of electron, they are going to be able to be attracted closely to this atom rather than if I compare with this, okay, because it's not going to be attracted so much over here because they are far, okay, they are far, and then they are not going to have a lot of nuclear charge. Therefore, the one on the right, they will have more electronegativity, okay, ability to attract electron, okay, because nucleus, the main point over here is nucleus is being very strong. If the nucleus is being very strong, the electrons, we are talking about the electron that is outside, not within, yeah, from outside. In this case, the bonding pair of electron, they can be attracted easily. So the ability will become more. Is that clear, Ashana? Okay, so when you go down, the ability also becomes less, okay, because they are going to have more shielding effect, okay, the distance is going to outweigh the increase in nuclear charge and so on. So the ability also will become less. So anyways, okay, this electronegativity can be measured by using Pauling scale. Now, according to Pauling scale, okay, this Pauling scale value, they are going to actually give the value from 0 to 4. 4 is going to be the greatest in electronegativity. 0 is going to be the least electronegative. And we can actually measure or use the value, the difference between them, okay, to find out whether this is going to be ionic, whether this is going to be covalent, and so on. For example, if your electronegativity value, yeah, the Pauling scale, the electronegativity difference value, I use EDV, okay, if this value is going to be greater than 2, okay, what can you say? You can say that, okay, this is going to be ionic compound, okay, the bond is ionic. Now, if your, okay, EDV, okay, difference, yeah, difference of the Pauling is going to be between, okay, more than 1, okay, more than 1 and less than 2, okay, more than 1, okay, and then less than 2, then we can say that, okay, this is covalently bonded, okay, covalently bonded, but with ionic characteristics. Okay, you can refer to my notes. Okay, covalently bonded, but with ionic characteristics. Now, if it is going to be, EDV is going to be, the difference is going to be less than 1, okay, less than 1, okay. EDV, okay, EDV stands for, I write down, okay, electronegativity difference value, or the difference in Pauling scale, okay, the difference in Pauling scale, yeah, so between that two numbers, you find the difference. Now, if the value, okay, is going to be less than 1, then it's going to be covalent, okay, with no ionic characters. But, okay, if your electronegativity difference value is equals to 0, okay, like Cl2, Cl and Cl, same electronegativity, you find the difference is 0, then it is going to be perfectly covalent. Okay, you can find all this information. Okay, it is in your syllabus. Okay, so please take note of this. Okay, this is about electronegativity. Now, I will go